my name is Amy, and I'm part of the education team here at Science East, and I'm a physicist. Now this is Pride Month, and I'm certain that you have seen the Pride flag or the rainbow flag all over town. So I wanted to ask the question, what causes rainbows? The short answer is refraction. But what does that mean? Light behaves like a wave, which means it can be organized into a spectrum according to its wavelength. So here we have light with a shorter wavelength, and here we have light with a longer wavelength. Now the light that we think of, the visible light, that is light that we can see, only makes up a teeny tiny part of this spectrum. But as you can see, it's organized in our very familiar rainbow. So red light has a longer wavelength, whereas blue light has a shorter wavelength. So how does refraction work? Well, here I have a red laser. Let's see what happens when I turn it on. So the really special thing about lasers is that they emit light at just one wavelength. So here you can see we have red light. Here I have a prism, and this prism is made of glass. Now refraction is what happens when light passes from one material, in this case the air, to another material, which is glass. What do you think is going to happen to the light when I put this prism in the way? Let's find out. So here you can see that the laser light starts off straight, but when it hits the prism it refracts, which means that the light is bent. Now let's see what happens when we change the color of our laser. So here I have a green laser pointer. Now if you remember from our spectrum, green light has a shorter wavelength than red light. So what do you think is going to happen when I shine this green light through the prism? Let's find out. So here's our red light and now our green light. So as you can see, the green laser light and the red laser light start out parallel to each other. But when they refract and come out the other side, now they're no longer parallel. And that's because light at different wavelengths refract at different angles. So what does this have to do with rainbows? When do you usually see rainbows? Usually you see them after a rainstorm. So what's happening is sunlight, which is white light, is passing through rain droplets, which are acting like little tiny prisms. So let's see if we can make our own rainbow. So here I have a lamp that has a white light bulb. Now white light is the combination of all the different colors of the rainbow. And so when this light hits this prism, all of those different colors are separated. And so we should be able to see a little tiny rainbow. Here you can see our little tiny rainbow. So this is the white light that's been separated into different colors. So this side you can see is a little more orange, and this side is a little more blue. So this side is the light that has a longer wavelength, and this side has the light with the shorter wavelength. And they're all separated because of the process of refraction. You know the science behind rainbows. The key is refraction. So now every time you see a pride flag, I hope you remember